Good morning, everyone, and welcome to the November 2023 edition of the Southeast Monthly Climate Webinar, where we talk about the climate and special topics pertaining to the Southeast region. My name is Chris Fuhrmann. I'm the regional climatologist with NOAA's Southeast Regional Climate Center, and I'll be giving a climate overview of the past month. Our other speakers today are Todd Hamill from the Southeast River Forecast Center, who will provide a water resources update, Pam Knox from the University of Georgia, who will provide an agricultural impacts update, and this morning, we're pleased to have Michelle Leroux from NOAA's Climate Prediction Center, who will be giving us an update on the El Nino Southern Oscillation and discussing the upcoming winter outlook for the Southeast. So again, thank you all for joining us. Just a reminder to type your questions and comments into the question box at any time, and they'll be answered at the end. Also, a recap email of this webinar will be sent out with a YouTube link to the recording in the next few days. All right, so let's get started with an overview of the climate. So over the past month, we saw mostly above average temperatures across the Southeast, especially across northern portions of Alabama and Georgia and eastern portions of Tennessee, where some locations were more than 5 degrees above average. In addition, unusually warm weather continued to persist in the Caribbean. San Juan, Puerto Rico is on track to record its warmest November on record and is just 0.2 of a degree shy of matching its warmest year on record with 1 month still to go. Okay, next slide. So in terms of precipitation, we saw a continuation of dry weather across the interior of the region, where the biggest deficits overlapped with some of the largest temperature anomalies. And this led to significant degradations in the U.S. Drought Monitor, which we'll look at on the next slide. Several locations recorded less than half of their expected precipitation over the past month, with some places only picking up about a quarter of their expected amount, at least based on climatology. On the other hand, a non-tropical disturbance dropped between 6 and 12 inches of rain across parts of the Florida Peninsula and the Florida Keys between the 13th and 16th of November. Pockets of above average rainfall were also noted across coastal sections of Puerto Rico, including San Juan, while below average totals were observed across the interior and southern end of the island. Though not shown here, several CoCoRaHS gauges recorded beneficial rainfall across parts of the U.S. Virgin Islands. Of note, between 5 and 10 inches of rain has been recorded across St. Croix since the beginning of the month, which has led to improvements in the drought there. Okay, next slide. So looking at the drought monitor, as expected, we see an intensification of drought across the interior of the region. Most notably, a large area of extreme drought emerged across Tennessee, northern portions of Alabama and Georgia, and the Western Carolinas, with a ribbon of exceptional drought spreading across eastern and southern portions of the Tennessee River Basin. Elsewhere, we saw extreme drought emerge across the Shenandoah Valley of Virginia. We saw it also expand across northwest Florida and southern portions of Alabama and Georgia, and persist across the west coast of Florida. We also saw severe drought emerge across the Carolinas and southern Virginia. As of last week, about 2/3 of the region was in at least moderate drought. The last time drought conditions covered 2/3 of the Southeast Dews region was March of 2011, though the droughts of 2016 and 2019 came close. Only the droughts of 2007, 2008, and 2000, 2001 had greater coverage across the region during the drought monitor era. Okay, next slide. Looking in the Caribbean, we see mostly improvements in drought conditions, particularly in the U.S. Virgin Islands. Of note is the appearance of moderate drought on St. Croix, which, as you may recall, was an exceptional drought just a couple of months ago. St. John is now free of any dryness, while a 1-category improvement was noted on St. Thomas. Conditions continued to improve along the northern and southern slopes of Puerto Rico, with just a small pocket of moderate drought persisting in the northwest. Okay, next slide. So we still have a few days left in the official hurricane season, but if we don't see any further activity, then we'll end the season with 21 total storms. This includes 19 named storms, one subtropical storm back in January, and 1 tropical depression in October. Of these storms, 7 became hurricanes and 3 became major hurricanes, which are Category 3 and higher. 6 of these storms, including all 3 major hurricanes, impacted the Southeast region, including Puerto Rico and the U.S. Virgin Islands. Based on data over the period 1991 to 2020, the 19 named storms is above the average of 14, while the 7 hurricanes and 3 major hurricanes are right at their 30-year averages. The accumulated cyclone energy produced over the season is running about 120% of normal, which according to the CPC puts this season in the above normal category. Okay, next slide. So looking ahead over the next 3 months, we see that the multi-model ensemble continues to forecast above average temperatures with near average precipitation over much of the Caribbean. And Michelle will cover the winter outlook for the mainland Southeast in her presentation later on. Okay, next slide. Looking at the seasonal drought outlook, we see a little more optimism than we did last month, with drought removal likely across much of the Southeast. Improvements are also expected across central Virginia, northern portions of Alabama and Georgia, and western North Carolina. While dryness, though, is expected to persist across northern Tennessee and in the Caribbean, fortunately, no new development is expected. Next slide. So for the next 6 to 10 days, as we turn the calendar to December, we see fairly high confidence in a warm and wet pattern across the entire region. Next slide. And this pattern is generally reflected in the 7-day QPF. This is from yesterday afternoon, where at least some precipitation is forecasted nearly everywhere, except South Florida, with a swath of over 3 inches expected from southern Alabama and northwest Florida through much of Georgia and into the upstate of South Carolina through early next week. Okay, next slide. Looking out to 2 weeks, we see warm and wet weather persisting across most of the region, except in Tennessee and northern Alabama, where precipitation is leaning below average. Okay, next slide. And then if we look out 3 to 4 weeks to mid-December, we see a bit of a pattern shift with respect to temperature, with much of the southern tier of the region running cooler than average, while precipitation continues to lean above average, except across the interior of the region. Okay, next slide. Okay, well, I appreciate everyone's attention. Here's a summary for you to look over after the webinar. I also want to mention that the Southeast Regional Climate Center will be unveiling the first version of an expanded Caribbean section of our quarterly climate impacts and outlook report. That'll be out next month, so be on the lookout for that. We'll provide a link to it in the webinar recap, and please let us know if you have any comments or suggestions. All right, so with that, I'll go ahead and turn it over to Todd for our water resources update.
Thank you very much. So I'll go ahead and get started, and we'll go to our first slide and our next slide. And so we're going to look at 28-day stream flow, and this is the 28-day average stream flow from the USGS. And on your left-hand side, kind of shows a snapshot of all the stations across the Southeast. And one of the things that you'll notice is that we've got a lot of below normal, well below normal, and I think a couple even areas that are even as low as they've ever been. So we're fairly dry when you look at the 28-day average. As you start coming into the coastal plains, in some cases, we do have a little bit more normal flow. It hasn't been quite as dry in the middle of the basins through central Alabama, central Georgia, central South Carolina. Hasn't been quite as dry in those areas. However, that's impacted in some cases by the flows from the reservoirs upstream and so forth. And so as we look at the right-hand side, one of the things you'll notice is we start to look back at the last 2 years. On the right hand, the black line shows where we are. That's our observed average stream flows across the whole Southeast. And you'll notice at the very, very end of this, we start to turn up. We start to go from being at a very low. And so our recent rainfalls has helped generally over the Southeast to start to see a change in that. Now, we've been very dry in the last month up until recently. And so what I did was, instead of just doing a 28-day average, because the 28-day average kind of takes out all the wiggles and everything else, and it kind of smooths the data out. Let's go to the next slide, which is going to show the 7-day average stream flow. And when you look at the 7-day average stream flow, one of the things you'll notice on the left-hand side is a lot more green, especially up in Virginia, up in North Carolina, in many spots up in northern Alabama. So you're seeing a lot more green through that area as opposed to the red. Now, again, this is only a 7-day average, and so it doesn't include earlier in the month, but you'll notice that even on the right-hand side, instead of being just a slow up, that we really are starting to see at least some improvement. But as you look back over the full 2-year period, you can see a lot more wiggles in that data. And so, you know, it is possible that we could creep back down a little bit and we might see some fluctuations, but this does show in the short term that we're starting to see at least some improvement in the stream flows in the southeast in hopes of that we're finally starting to turn the corner from the drought and be more wet as we get into winter. Now, I did not do this for all of the different states, but let's go ahead and go to the next slide and look at the 28-day averages for each of the different states. So on the first one on the left-hand side is Alabama, and you can see that it has started to change. This is the 28-day average, and you can see at the end of the period, we've been in dry conditions, below normal conditions for the last, since September really. And looks like we're finally starting to creep out of it. We finally started to get enough rain that maybe we're going to be out of it soon. And again, this is the 28-day average. If we looked at the 7-day average, we likely would be out of that. But it does kind of give you an idea that this is the climatology. We were at the lowest time of year, and it does look like we're improving more quickly than maybe climatology says. So that's good news for us, concerned about the drought as we go forward. As we look at Georgia, we haven't seen that turn quite yet. We've been very dry in part of the state. We probably didn't see quite as much rainfall in this last event, and we haven't seen much over that time period. So we haven't started to see that improvement yet. And then when we get down into Florida, while they've gotten dry, they have improved to the normal range in that area. So we are starting to see improvements in that area. So let's go at the Atlantic coast and look at the next slide for South Carolina and North Carolina. South Carolina, you can see they have been very dry again since that mid-October time frame, and they are starting to turn too, but it is very slow, and we'll see how quickly it starts to get back up more into the normal range. North Carolina is also, you can see that it's starting to creep up a little bit, and it had a little bit more rain this weekend, in this past weekend, and I think our 7-day did show it going up pretty quickly. And the same goes for Virginia. Virginia saw some pretty heavy rain in those areas. Also, as I mention all this, remember these rains that we get now are much more productive because there aren't as many leaves on the trees, and there's not as much competition for that rainfall, and so we tend to get more runoff from these rainfalls. And so each successive rainfall that we're going to see should start to produce more runoff. And as was mentioned before, we are looking at a wet week and more wet as we go forward. It does seem like that pattern has changed for us. So let's go ahead and go to the next slide. And so this is just what we've got going across the southeast. And again, this isn't unusual. We have a little bit of flooding going on in Florida, and that's for a variety of reasons. We've had some heavy rain in those areas. We've had a lot of northerly winds that have kept that water from draining out of Jacksonville. So that's there's been a mix of things going on in Florida. But overall, we don't have any flooding in the area. Things are well below flood. So hopefully we will see as we go into the winter, this may change a great deal. So let's go ahead and go to the next slide. And so we're in week 48. We're getting near the end of the year. Now these are southeastern forecast center area floods, and when we expect, and I always talk about this, that we can expect, floods can happen during any week of the year. This is the time where it's still a little bit quiet, but we're coming out of that quiet period and starting to get into the late November and early December, and that ramp up with the little competition for water, more frequent rainfalls, and more runoff. And so as you can see, we're starting that ramp up of potential flooding during this time, but this is both a flood season and a recharge season. So we expect this as part of our climatology to fill our reservoirs and to fill groundwater and everything else. We need this going forward. So it does look like we'll see improvements as we go forward, just simply from a climatology standpoint. But we're coming out of that low and that lull as we get into November and into late October and early November and going into December. So that's week 48 for the southeast. And our next slide will show what Florida is. And Florida, we're at a very low period. This is always in between the wet season and then the winter season. Now, it's usually dry season as we get down into Florida, but this during El Nino years, oftentimes we do end up having wet years. And most of the rainfall, most of the flooding that you see over the next 8 to 10, 12 weeks happened because of El Nino years and getting lots of rain down in Central and South Florida and having those floods. So this is one of those years. So it's kind of what we're expecting going into this winter. So let's go ahead and go to the next slide. So I'm going to steal a little bit of Michelle's thunder, and I apologize, but so I can talk about our forecasts and so forth. This is the Climate Prediction Center's outlook for December, January, and February. So as we start to talk about what how this is going to impact the rivers in the southeast, right now we are looking at above normal rainfall, and because of that, our forecast for the rivers is looking at this. And Michelle will go into some details about why it looks like this and what it and why we're likely to see this type of forecast for the next couple of months. So let's go ahead and go to the next slide so we can, and I think we've talked about this in the last month or so, is the winter flood outlook. And these are moderate to strong El Niños. And I know I've talked about these analogs before, and I'm planning on this being the last time I show them, simply because I hope we're going to be out of this and we're going to be talking about we're going to be talking about at least normal stream flows through that period, but that for December, a lot of these areas still stay below normal, kind of like where we are right now, that we come out of a dry part of the year and it takes a while to recover from that. Some years it's earlier, some years it's less, but these pie charts indicate above normal, where the green is above normal and the yellow is near normal on those stream flows in those particular basins. And so you can see over most of those, we're at least normal to above normal. And for the most part, those below normals are smaller. They're not very big. In some cases, they cover about a third, which would be kind of an in-between type situation. However, this wouldn't be unusual as we come out of a dry season, which if we don't have a whole lot of tropical weather, which we didn't this year from what impacted the southeast, so we ended up being a little bit dry. And so, but as we approach January and February, it seems those red areas start to get a lot smaller, especially in Alabama and Mississippi and Georgia. And so by the time we get to February, things end up being pretty wet, at least normal to wet in the southeast. So let's go ahead and go to the next slide. And so we're looking, as we look at a late fall, early winter outlook, December through February 2024, we are looking at above normal risk for flooding in the southeast. We do not expect by the time we get to that especially once we get to that February timeframe, that we're going to see any more drought in our area of the southeast, and that our risk for flooding is very high simply because of the El Nino forecast and the potential rainfall we're going to see during this winter season. And let's go ahead and go to the last slide, and I believe that is our summary slide. So that kind of goes over a lot of the things we talked about, and you can read this afterwards if you and just kind of for everything. So if no, but we'll answer questions later. And so now we'll head and talk to Pam.
All right, well, good morning, everybody. I'm glad to be here. It's a nice day outside today. If you were listening to Todd's presentation, you know it could be a pretty wet spring. So if you are somebody who plants crops in the spring, you might have to keep in mind that things could be delayed by the wet soil. We'll be watching that as the months go by. So let's jump right in. Here's a bunch of the impacts we've seen recently on agriculture. Biggest weather impact really, especially early in the month, was the lack of rainfall, which Chris talked about, continuing to cause problems for forage producers and livestock producers that have to feed their cattle, and also small grain farmers, because they need to put the seed in the ground and have it wet enough so that the seed can germinate. So that has been an issue for some people. Of course, now we're getting pretty late in the season. A lot of areas have had frost. And so In some cases, they'll probably have to delay until spring to plant something different. We've seen more activity with wildfires in the driest areas, causing problems with air quality, and also some transportation issues just because it's blowing smoke across some of the roads, and so that has been more of an issue. That's been especially true in eastern Tennessee and western North Carolina, where there, of course, a lot more forest and a lot of tree covers. I've seen some pretty spectacular videos of fires along the Tennessee North Carolina border. The recent rains that we have had have allowed some grain planting to continue. Most farmers are still feeding hay to their cattle because they haven't had enough growth, although the latest crop progress newsletter did say that pastures are starting to green up, so that's good. Hopefully they'll be able to start feeding the cattle pretty soon. Most parts of the region have experienced at least one night of freezing temperatures, except for southeast Georgia and Florida. So that has pretty much ended the growing season in those areas. I've got a slide on frost in just a minute. In warmer, wetter areas, they've been doing a lot of strawberry planting and vegetables. They've been doing pretty well. Disease pressure has been quite low. You can see the picture there on the top left. The deer are certainly loving all those vegetables and strawberries, and so they have to put fences up to keep the deer out as much as they can. And we've also noticed that the pecan harvest is down about 30% in Georgia this year, partly due to all the damage from Idalia, and also dry conditions later in the summer when the nuts are filling. In Florida, they've been wetter, and so the wet fields have led to some issues with citrus and crops, but overall they're in much better condition than other parts of the region. So let's go on to the next slide. There we go. Here are some of the impacts of conditions on agriculture. This is a cotton field that did not do well this past year. And I need to remind you all that this is the best time of year to diagnose what went wrong with fields that did not do well. Could be a problem with the seed, could be a problem with the weather, could be a problem with your management, how they were planted, how often they got fertilizer and other kinds of chemical applications. But you want to do that in the fall because there's nematodes in the soil in many cases, and you can find them much easier in the fall at the end of the growing season than if you wait until next spring. So I have instructions from Bob Kimmeray in Georgia to make sure that everybody knows this is the time of year you need to diagnose in preparation for next year. If we go on to the next slide. There we go. Soil temperature has been above normal because we've had quite a bit of warm weather and it's been dry. So of course, more of that solar radiation can go into heating the soil. Soil moisture in the last week. This is surface soil moisture, so it responds pretty quickly to the rains. Shows much improvement. There are still some dry areas scattered around North Carolina and southwest Georgia, but there is some improvement in that. And we hope to see that continue, as Chris said, with all the rain that's coming. So if we go to the next slide, we're still thinking about frost. Of course, a lot of areas of the southeast now have had their first frost. The image here on the right-hand side shows a bunch of the stations and how many days they've had a minimum temperature of 30 degrees Fahrenheit or below. So it's not just touching frost, but it's actually getting down into the freeze area. And you can see there's a pretty large part of the region that's had that. The only parts that haven't are down into Florida, and then the coastal plains in Georgia and South Carolina. I expect some of those areas are going to see frost tonight. We're supposed to have another cold blast come in. Is that we expect this time of year. The average frost dates on the left-hand side there, we're in the light green this week. Next week we'll be in the dark blue. So you can see we're right around the average time period for the first freeze of the fall. And so we'll be watching. You might not know, but the Weather Service usually stops giving freeze outlooks once a location has had a killing frost. And so you're probably not going to get any more freeze notifications at that point from those counties. So that's something to keep in mind. Keep watching the forecast if you're worried about frost affecting your areas. If we go to the next slide. I did want to mention also that there is a new USDA plant hardiness zone map. If you're a gardener and you plants depending on what the plant hardiness zone is for your location. You'll want to check this out. You can see on the right hand side there is a map that shows the half zone changes. Plant hardiness is related to the lowest minimum temperature a location is likely to get in a year. You can see almost more than half of the Southeast has jumped up half a zone. So that means you're able to grow warmer crops that are suited to warmer conditions more than in the past. Of course, a lot of that has to do with the rising temperatures from climate change and global warming. Something to take a look at for the future, just to see what that is. The new plant hardiness zone map is really nice because you can actually zoom in. You can put in your zip code and it will zoom right to that area. And so that is someplace that can be really useful. I think it's something worth taking a look at if you're interested in putting plants into the soil. If we go on, that's it. I want to make sure I left plenty of time for Michelle so you could read my summary later. And I am very happy to have Michelle give us this outlook. I've been looking forward to it. So take it away, Michelle.
Thanks so much, Pam. I really appreciate it. So I'm always kind of excited to do the Southeast Climate webinar series because ENSO actually has a very strong relationship with precipitation in this part of the country. So unlike other regions, there is a little bit more uncertainty. Now, with that said, I will emphasize that uncertainty, and you're going to see that in the last part of this presentation. There's never a guarantee of outcomes with El Nino, unfortunately. So my role at the Climate Prediction Center is actually the El Nino Southern Oscillation lead, and there's a team of forecasters who are responsible for basically producing the updates each month. And obviously, you know, even though I'm focused on the El Nino status itself, it's the next question out of everyone's mouth is, well, what does that mean? So I'm going to focus the first part of these slides on just El Nino status itself, and then I'm going to transition and talk a little bit more about the impacts. Or next slide. Okay, so I guess unless you're living under a rock, you probably know from various media reports that we declared an El Nino back in, I think we issued a watch in April, and then we issued the advisory, El Nino advisory in June. And so we've known about this for quite a while, and but we have monthly updates here. And go ahead, next slide, or next click, yeah. That as of November 9th, we expect this El Nino to continue through the Northern Hemisphere spring. Obviously, we have high probabilities in the coming months, and then it starts to decrease as you get into longer time horizons. Our last season where we believe El Nino is favored is during that April, May, June season. And then after that, we're actually expecting a transition back to ENSO neutral, which basically means there's neither an El Nino or a La Nina. Next slide. So I won't get into too many details here, but there are a series of processes on the equator that lead to El Nino and La Nina events. The top left is showing the typical pattern of sea surface temperatures and subsurface temperatures, and also convection on the equator. And El Nino essentially disrupts all that. So the lower right there is showing that instead of having warm water piled up in the Western Pacific, we see that spread across the Central and the Eastern Pacific. And then we would also expect with that warm water, we get more rising motion and convection, and that shifts eastward. And what this can all do is have a cascading effect upon the teleconnections that we experience here in North America. And I'll talk a little bit more about that coming up. All right, so the question I want to ask is, are we seeing this? Are we seeing these telltale signs of an El Nino? And the answer to that is definitely yes. Next slide. So this is the sea surface temperature anomalies for the past month that we have data. This is only we're still waiting for our November average data currently. We'll get that in a few more days. But this is what October looked like, and as you can see, these are sea surface temperature anomalies, meaning the reds are above average ocean temperatures and the blues are below average ocean temperatures. And so you see the telltale sign of an El Nino there with all that warmth in the central and eastern equatorial Pacific. However, I want to bring your attention to the fact that there's a lot of warmth everywhere. The global oceans have been breaking records every month for historic warmth. So this El Nino is occurring in a very different backdrop than what we typically expect with these El Ninos, and that could have ramifications on the impacts that we see. Generally, warmer oceans mean more moisture. That doesn't necessarily always translate into increased rainfall or snowfall. Rather, it's just more available supply to tap into. So when the atmospheric conditions change enough and wring that moisture out, then it can definitely amplify potentially some of the effects of El Nino. Next slide, please. This is zooming in on the equator. So now we're just focusing on the tropical Pacific. And I'm showing weekly average data here. The previous slide was a monthly average and the evolution that we've been seeing more recently. So this brings us up to the present. And the big take-home message here is that not only are we seeing the telltale signs of El Nino, but we're seeing it amplify as we speak. The deepest red there's are above, even more above average waters. And we're seeing that spreading across the central and eastern Pacific. So it is strengthening as we get into this winter season. So it looks like a very robust, healthy El Nino event. Next slide. This is another perspective. This gives you a little bit more historical context of where this El Nino is ranking. And on the y-axis there is the Niño 3.4 index. Niño 3.4 is just a region in this east central tropical Pacific that measures those temperatures. And anything above that dashed line is considered, that horizontal gray dashed line is considered an El Nino. And you can see we're well above this dashed line. The black line is our current evolution. And then of course the x-axis there is showing the different months, and our most recent month, of course, is October. So that black dot line stops in October. But then we superimpose on it all the previous El Ninos dating back to 1950. We're also removing essentially trends and climate change. We actually use a moving climatology in order to rank this because we do have the influence of warming ocean conditions influencing our time series here. So I'm essentially trying to take that out here. And then looking at the strength of El Nino in the context of this detrended data. Anyway, the bottom line is that right now, if you look at the historical record of all these El Ninos, we're clearly in the threshold of a strong El Nino. We're ranked about, I think we're 1, 2, 3, 4, 5. Yep, we're ranked 6 right now, historically, if you look at all Octobers. And I would expect that line to jump up even more as we get our November monthly data. That will definitely increase. We'll see where we end up this winter. And as you can see, the sea surface temperatures peak during the Northern Hemisphere winter and then start decreasing as you get into that early calendar year, as you get into the spring. So that's the historical evolution of these events. Next slide. All right, this is subsurface. I haven't talked too much about this, but essentially this looks good too. This is our fuel for El Nino. So what occurs at the surface and what we see at the surface is often preceded by what we see below the surface of the ocean. And so one of the important conditions of a growing El Nino event is seeing essentially growth and lots of fuel below the surface. And we are definitely seeing that. In fact, as this animation goes forward, what you see is a broadening of those red shadings, meaning that we're seeing those subsurface anomalies amplifying along with the surface. Next slide. All right, so now let's get into the forecast. This is just for El Nino itself. All right, now the chances of El Nino are often very different from the chances of impacts. All right, so when we give these probabilities, we're just talking about the sea surface temperatures in the tropical east central Pacific Ocean. This is not the same probability or chance of a subsequent impact, because there's obviously a lot of chaos in atmosphere circulations, and we have to assume that there's these knock-on effects as we get, especially over North America. So what this is saying is that we're very confident in the chances of El Nino itself, close to 100% in the near term, and then slowly decaying as we get into the spring and summer. In fact, those gray bars is the neutral condition, and that means we're neither in that warming or cooling state. We're just in that climatological, more near average state, and we expect that to return as we get into May, June, July, August. All right, next slide. I want to apologize for this slide. I really don't love this table, but it is chock full of information. And when we're showing 100% chances of El Nino, that tends to bore some people. They're like, okay, that's nice, but how strong will this El Nino be? And this table basically answers that question in a not so friendly manner. But let me talk you through the highlights. Go ahead and click again. So this category here, so this is the chances of this east central tropical Pacific region being greater than 1.5 degrees centigrade. And that's essentially our threshold for a strong El Nino. And these numbers are showing probabilities. And so for the October, November, December season, through the January, February, March season, we have a greater than a 55% chance of a strong El Nino. And those probabilities decrease. We're actually in a strong El Nino right now, which is why the first forecast target there, the October, November, December season is so high. It's a 94% chance, and then it decreases as you get to longer time horizons. The other question people are asking is, okay, it looks like, you know, you're pretty confident in a strong event. What's the probability that we actually see like a top 5, top 4 event? And that's when you get into this greater than 2 degrees C category. Can you go ahead and click? And so at the peak, we actually have a 1 in 3 chance of a historically strong El Nino, what we informally call historically strong. So that means it'll be ranked among one of the strongest El Ninos in our record. 1 in 3 is quite high. I mean, obviously that's not 1 in 2 or even higher at this point. Keep in mind this table will update in a couple weeks. So these numbers will change, but 1 in 3 is quite high for forecast for a historically strong El Nino, and so we are within shooting distance of that. All right, next slide. All right, so let's get to the impacts. Next. All right, so this is schematic. I both love and hate this diagram. I love it because it gives you just kind of the overall depiction of what we expect for El Nino over the entire North America. So with that warmth in the central and eastern Pacific, what happens is the jet stream, which is this river of air moving from west and east, and storms tend to travel along the jet stream, that tends to respond. It's because that warm water is pushing to the east. The jet stream equivalently gets a little more energy and also extends to the east. And it also shifts a little bit southward across the United States. It's essentially attracted to that warm water. So anyway, you get the southward, eastward extension. You tend to have higher probabilities of wetter conditions across the southern tier and the southeast. Because it's wetter, you tend to have more clouds. And so historically, El Nino tends to nudge things in a cooler direction. But keep in mind, this is just historic El Nino impacts. We also have climate change on top of everything. So very rarely now, when you look at our official outlooks, do you see colder expectations, because we also expect that just with climate change and trends that there will be more warmer winters. So often we do not forecast below average temperatures, even when we have an El Nino, simply because it's so hard to get below average temperatures these days. Go ahead, next slide. Okay, so I wanted to try something new with this presentation and sort of quantify how well each El Nino winter matches up with the expected pattern. And I'm only going to look at the strong El Nino, since we have a fairly high chance of a strong El Nino this winter. So what this map is showing is zooming in on this southeast region, and those green shading means above average precipitation and the brown shading is below average precipitation. And this is just focusing on December, January, February season, which is kind of our target winter outlook season. And so this is historically, when we average together all the El Ninos, the pattern that we expect with it. And then I basically did a little bit of math. The details are really not that important. And I said, okay, if I take all strong El Nino winters and match them up with this typical pattern, which ones are the best match with this pattern? Which ones is the worst match with this pattern? So go ahead and click forward. Okay, so these are the better pattern matches with the typical El Nino pattern. So I deem these and quantified this, that these winters were especially El Nino-like. And again, these are all just strong El Ninos. And so what we see is that the strongest pattern is probably in 1997, 98. Maybe that doesn't surprise people, that's that top right. But we also had a pretty good pattern match in 2015-16, which was a historically strong El Nino. 2009-10 and 1982-83 were all pretty good pattern matches. Now, it's not perfect everywhere. You definitely see regions that are kind of left out of the El Nino action. Like, for example, that bottom right is showing 82-83, and I live in Virginia, and as you can see, Virginia was left high and dry during that particular strong El Nino. But overall, these were the nice matches. All right, go ahead and click forward. These were among, oh, sorry, no, go back. Sorry, just want to, these years on the left were among the poorer matches. And there's still like a lot of tilting toward wet conditions. So even for the poor matches with that typical pattern, you still see generally wetter conditions across the southeast. The big cautionary tale is this top left panel, 1957-58, occurred a long time ago, but that was a strong El Nino, and you can see we had a lot of dry conditions across northern Florida, Alabama, Georgia. So this is you know, a possibility. We always have to keep in the back of mind that El Nino is nudging the patterns in a certain direction, but it doesn't guarantee them. And there's a lot of chaos in our atmosphere, and so there's always surprises potentially. And that's why when you look at our maps, we tend to give percent chances of wetter conditions. We don't give you 100% chance, and it's because we have uncertainty like 1957-58. All right, next slide. So I realize this is extremely busy. Not everyone will totally understand what's here. It does take a little bit of time to study this plot, especially if you're not familiar with this sort of strategy. But let me just try and get the highlights here, and essentially articulating what I showed in the previous slides. Each of these dots is a different winter, all right? The number next to the dot is you know, denotes which winter. So if it's 84 is next to the dot. That means that was the 1983-84 winter. Okay, so I'm showing every single winter going back to 1950 here, and those all the dots. The x-axis toward the bottom is whether we were in El Nino or La Nina state. We're obviously going to focus a little bit more on the right side of this axis. Those are El Nino values, and so the larger the value, the stronger the El Nino. And then on the y-axis is that match score. This is that math that I use to basically say, how well does each winter match up with the expected or typical El Nino pattern? All right. And what I find, which isn't too surprising, is that you tend to have more of these positive, these larger match scores. Larger values means the winter precip pattern looked more like the typical El Nino pattern, the stronger the El Nino is, all right? And those scatters, there's a lot of uncertainty, but there is a black line that's on the diagonal there, and that is essentially the expectation. So with El Ninos, you expect more positive and better match scores with the typical pattern. And then at La Niñas, you actually expect the inverse pattern. We're not going to talk too much about that, but you expect opposite sign patterns. The yellow area is the strength that we expect this winter. And essentially what El Nino is telling us is that we're probably going to see better matches with that expected El Nino pattern, but there is some variability about that, right? You can see 58 there, that's 1957-58. That was that poor match winter. And there's a certain amount of spread that's intrinsic to this. And so we can certainly see another 57-58 style winter. We wouldn't expect that though. We would expect something closer to that black line or even greater. So we'll see where we end up, but this is the uncertainty that we have in our seasonal predictions. All right, next slide. All right, and so this just reinforces what you saw before. It's sort of now you have a little more context on what these probabilities mean, and on the left there are the percent chance or the probability of above average precipitation that includes both rain and snow. And essentially Southeast is one of our more confident regions for El Nino impacts. This is just for December, January, February, but if you look at all the maps for the upcoming seasons, which our CPC seasonal outlook team puts together, you'll see these enhanced chances persisting through the spring, April, May, June. On the right, there's temperature outlook. For the northern parts of this region, we expect a tilt toward warmer conditions, and then the rest of the regions is white, and the white just basically means we don't know. We don't know whether it's going to be above, below, or near. And that expectation in part is driven by the fact that we, again, don't tend to see below average temperature winters. And so we may see that, but we may not. And it's possible these trends will just win out and we could see above average. All right, next slide. Okay, so these are our takeaways. We have a strong event is currently strengthening. It is not weakening right now, it is growing. So we'll see where we end up, but 1 in 3 chance of historically strong El Nino is up there. And we'll see whether that pans out. The expected peak, again, the sea surface temperatures will peak in the coming months, the next month or two, but the impacts lag. The impacts will lag into the spring seasons, and that's very, very typical. Over the Southeast, above average precip is likely. Above average temperatures are favored toward the north with equal chances over most of the regions. And again, I really want to, you guys are lucky on some level because you do have these stronger El Nino relationships, but even with that, there is bus, even for a strong El Nino, which is really loading the dice in favor of this above average precipitation winter, there is always a probability here, and you could always have something that's like 1957-58. All right, and that go ahead and that wraps things up. Those are some links that you may be interested in, and so updates. We also have a blog where we try and educate the public about uncertainty and El Nino impacts, and then of course the CPC seasonal outlook has a link there. Thanks so much. I really appreciate this.
That was fantastic, Michelle. I'm always amazed at your skill in taking a really complicated and unfriendly graph and talking us through it in a easy to understand way. So Thank you. My name is Meredith Muth. I work at NOAA's National Integrated Drought Information System, and we co-organize this webinar series with the National Weather Service and the Southeast Regional Climate Center. If you have any questions for any of our speakers or comments on anything you heard today, please go ahead and enter it into the question box, and we'll answer them in just a moment. The next webinar, we will not be having a webinar in December. However, in January and February, we've got a couple of great ones lined up. We'll have the National Centers for Environmental Information give a review for the Southeast, looking back on 2023. And then we're really excited to have a presentation on the Southeast chapter of the National Climate Assessment Report that was just released a couple of weeks ago. We'll make sure that you have some of those links in the webinar recap as well. And when this webinar ends, if you have any comments on topics you want to hear about or ways we can improve this long-standing webinar series, please go ahead and take a moment and complete the survey that pops up. So what I'm going to do now is we have a couple of questions coming through. I'll also, if any of our panelists has anything they would like to add, just let us know and we'd be happy to give you the mic back. Our first question is going to be for Michelle. Michelle, there is some relationship mentioned between El Niños and polar vortexes. Could you explain that and maybe talk a little bit about what are the chances of polar vortex events in the eastern US?
Yeah, no, it's a really, really good question. So there's a lot of different ways to answer that question. So El Niño, if you look at it historically, at least for the winter, it tends to nudge the polar vortex. And by polar vortex, I'm talking about essentially the jet stream encircles the whole northern hemisphere, and it basically bottles up cold air close to the Arctic. And when the polar vortex weakens, it basically allows that cold air to surge southward and impact, say, the United States and the eastern United States. So if you look at historic El Niño events, they do have a slight nudge toward polar vortex weakening. That might not be a coincidence. Historically, again, below average temperatures tend to be favored across the southeast with El Niños. More often than not, this day and age, it tends to not be as below average. It may feel relatively cooler, cooler than, say, the previous month or previous set of seasons. But when you look at it historically, it is still quite hard to actually get below average relative to the base periods that we use. And so, there may be some interplay there in the sense that that below average that is favored is in part because of polar vortex weakening, and so there might be a little bit of expectation. The big caveat is that I'm talking about a pattern, El Niño, that is predictable. We can talk about this. We've been talking about it since essentially April. We actually said that there was a decent chance of it being a strong El Niño when we declared the arrival of El Niño in June. So this is all evolving in a very predictable manner. The problem is the polar vortex is a lot noisier. It fluctuates a lot more from month to month, from season to season. It is much less predictable. And so the variability, the range of variation tends to be very high. And we can't say with a lot of confidence of where it will be as a result of that. But El Niño may nudge things a little bit toward that weakening of the polar vortex. We'll see what happens.
Thanks, Michelle. All the questions are for you.
It's okay. And if anyone else has something to add in, definitely chime in.
Absolutely. This is an interesting question. Has there been any research into what happens the winter following a strong El Niño event?
No, that's a great question. So, yeah, so we have all those probabilities going out 9 months, but we don't have anything going out farther. But the reality is there is probably a little bit more predictability than we're showing there. And if you just look at our table of El Nino and La Nina events going back to 1950, and you count, all right, if we're in El Nino, what does it look like the following winter? About half the time you get a La Nina the following winter. And that's just based on the statistics of, you know, whatever 25 El Nino events and El Nino winters we've had. About half of them have been followed by a La Nina. Stronger events tend to load the dice even more in terms of La Nina. So the problem is we don't have that many strong events. We're talking a small sample size, less than 10 here. And so it's not a large, as scientists, we like to have more examples, and that's a small set. But in general, stronger El Niños do load the dice in favor of La Niñas the following winter. And that is something that shows up in the research, that shows up in our 12-month forecast runs that some of these models range out to. There is actually a push to push these models even farther into multi-year forecasting, which quite frankly, I think is appropriate in times when we have strong El Niños like we do now. That might be what's called a forecast of opportunity. So we'll see, but right now I would keep your eyes on those probabilities as they update each and every month. And this is obviously something that the forecast team is aware of, and we will be watching that possibility very closely.
That's great. Next question is related to the Pacific Decadal Oscillation, the PDO. Is there any impact on the phase of the PDO on ENSO in respect to this year's strong El Nino?
Yeah, so a lot of people have been pointing out the PDO is negative, and the PDO is basically sea surface temperatures across the North Pacific Ocean. The issue there is that the PDO is a very it's very, I'm trying to put this in English, I want to say red phenomenon, but that's not great English. It tends to have memory that extends back previous winters, and part of the reason that the PDO has been negative for a long time is because we were in a La Nina. We had 3 back-to-back La Ninas. And the PDO really only changes its shape and its intensity during the winter. And it does that in the winter because that's when the North Pacific storm track picks up and you start getting more of this wave action at the surface, and it starts influencing the sea surface temperatures. So in other words, we have an El Nino coming back, and that may nudge the PDO in a certain pattern once that wave action starts picking up across the Pacific. So yeah, it's certainly something we're looking at, but I do think that with the El Nino we expect we would actually start to see a weakening of those negative PDO values, and even getting back to a more neutral PDO state as we come up here. So we're at this point, at this, the brightest minds in seasonal forecasting do not think this will be a major player here. I'm actually a little bit more concerned about the global ocean warmth that we're seeing. You wouldn't call that PDO, but there is a very warm ocean that, again, the moisture could tap into and really amplify some of these rainfall effects if they happen. So that's something I think we need to be mindful of.
I think we have time for 2 more questions. If we did not get to your question, there's quite a few, we will, if it's okay, Michelle, I'll send them to you.
Oh yeah, I have time, so go ahead.
Okay, excellent. Okay, pull out your crystal ball again, and I think I know your answer, but is there any, do you expect El Nino to be finished in May or June of 2024?
Oh, wow, that's a hard question. So one of the reasons we focus on 3-month seasons is because El Nino impacts 3-month seasons much better than it impacts a monthly average or even a weekly average, especially a daily average. Good luck trying to find El Nino in that. So 3 months is really why we are saying that May, June, July is when we would potentially see a return of ENSO neutral. It's really hard for us to say which month. Like, I could guess, but it would just almost be random at this point. It will be sometime between May, June, July at this point that we're favoring it. Obviously, I think May, June, July is a 60% chance. So there's a 40% chance we would not be in neutral by then. But it is really hard to pinpoint on a monthly basis. We don't like to look at El Nino on monthly basis. The relationship is just not as strong. It's a good question though.
That's an excellent point. Okay, the next one will be a very technical question, and we'll follow up with a light one, and then we can wrap it up. Michelle, this is related to the multivariate ENSO index, MEI. Any thoughts as to why the multivariate ENSO index has not aligned with El Nino 3.4 sea surface temperature trends?
Yeah, I don't know enough about this. I do know what the MEI is, but my understanding is the MEI is also showing an El Nino. So I'm not sure what this person means in terms of not being aligned. Maybe it has to do something with the intensity of the MEI, and it's not as strong as the Niño 3.4 index. If that's the non-alignment, I would counter that by saying that a lot of these ENSO indices are different values and different intensities. So Niño 3.4 is the one we focus on for very specific reasons. But if you look at, say, the OR index, that's on the weaker side, tropical Pacific. If you look at SOI, that's a different ranking. All these different ways of measuring El Nino have different rankings. So it's not unusual for any El Nino event to have different rankings among different indices. So I would just say the MEI is another ENSO index is showing El Nino state, and it has a different ranking.
Great. And we'll just wrap this up with a comment that somebody submitted. Michelle made an initial remark that almost everyone has heard that we are in El Nino right now. And it turns out that a Hallmark Christmas movie this year actually mentioned El Nino.
No way. That's so funny.
We are famous.
That's so cool.
Anyway, just wrapping this up.
That's when you know you have penetration, is when you make a Christmas movie.
I love it. Anyways, many thanks to all of our speakers again, and all of you for joining us. Look for the webinar summary, and we will see you. I can't believe I'm saying this, but in 2024.
Wow.
So again, enjoy your holidays and stay safe. Bye.
All right, thanks everyone. Bye now.